Hi guys, welcome to Vedant EduNation. Today I have got another problem in electromagnetics, which I picked it from GATE papers, one of the previous GATE papers. So here is the question. So consider a uniform plane wave with amplitude E naught of 10 volt per meter and 1.1 gigahertz frequency traveling in air and incident normally on a dielectric medium with complex relative permittivity epsilon r and permeability mu r as shown in the figure. The magnitude of the transmitted electric field component in volt per meter after it has traveled a distance of 10 centimeter inside the dielectric region is. So this is the question, and here you can see the schematic of this problem. So there is electric field of 10 volt per meter and frequency 1.1 gigahertz. It's traveling in air, and then it's incident on a dielectric medium with the mu r as this and epsilon r as this, which is both are same value, and we have to find the value of E at 10 centimeters inside the dielectric medium. So as you can see, this is a normal incidence, so you don't have to worry about the direction oblique incidence part. So you just have to see now that once it is incident on this dielectric medium, what is the reflected wave and what is the magnitude of the reflected wave and the transmitted wave. So first what we will do is to find the magnitude of the transmitted wave. So once you know how much it is transmitted, let's call it ET. Then you can see how much is the electric field at this point. So this dielectric is lossy, so the electric field is going to decrease from the entry point until 10 centimeters, and we have to find the attenuation constant here. So the second part would be to find the attenuation constant which is usually denoted as alpha. So the electric field at 10 centimeters inside the dielectric medium, we call it ET10, would be the electric field which is transmitted, which is ET exponential minus alpha z, where z is 10 centimeters, which is given in the problem. Okay, so now it looks quite straightforward, but still you have to remember quite a bit of formulas. Okay, so first thing is, what is the transmitted wave? So we know from the electromagnetics that the transmitted power or the transmitted ratio, let's call it T, is given as 2 neta 2 divided by neta 1 plus neta 2, where neta 1 and neta 2 are the intrinsic impedance of these two mediums. So the intrinsic index is neta 1 and intrinsic impedance is neta 1 and this is neta 2. So the first thing is to see what is the formula for the intrinsic impedance. So eta, which is given by square root of mu by epsilon for a given medium. So in this case, this is a dielectric medium. Let's call it mu d and epsilon d. So mu d and epsilon d. So this is given as mu naught mu r, which is given in the problem, and this is epsilon naught epsilon r. So now we know what is the intrinsic impedance of this dielectric medium. So let's calculate T. So T is equal to 2 into, which is, we will plug in this one here. So mu naught, so let's say just eta 2 here, mu r divided by epsilon naught epsilon r divided by eta 1, which we know for air is just mu naught by epsilon naught plus, it's again the same, so mu naught mu r divided by epsilon naught epsilon r. If you solve this, you will just get T as 1. So it means that the wave is fully transmitted, so there is no reflection at all. The R is 0 and transmitted is 1. So ET here, which is the transmitted wave, is just 10 volt per meter. So now we have done this part where we found out what is the transmitted wave, which is still 10 volt per meter. So ET here is 10 volt per meter, here this is 10 volt per meter. Now we have to find alpha. So alpha is the attenuation constant. Attenuation constant for a dielectric medium is there is a formula that we can use. So alpha is equal to, so I'll just copy this from the cheat sheet I have for such formulas, and you should have one too while attempting to solve such problems. It's really good that if you just memorize these formulas, because in the exam it will be very quick if you know the right formula, and if you apply the right technique it will be quite quick. Also the gate questions are such that if you apply the right formula you can solve them quite easily. So I will just copy the formula on this alpha. This is the attenuation constant in this dielectric medium, which is a lossy dielectric medium. So omega naught. So this is quite a big formula, so I'm just going to write it down. So epsilon dash mu dash divided by 2, and you have 1 plus epsilon double dash square, and you close it again, and 1 plus mu double dash square, and you close it again. So okay, so this was not required, and you have the square root of this, and you have 1 minus epsilon double dash mu double dash, and you take the square root of all of this. So this is quite a big formula, but it fits very well with this problem here. So you know that mu, so what we need to see what is epsilon dash, mu dash, epsilon double dash and mu dash. So given here is mu r, so mu r is usually represented as mu dash r. It's a complex permittivity, so permeability, so mu r double dash, and epsilon r is epsilon r dash and epsilon r double dash. So this is the real part of epsilon dash is the real part of your permittivity, and mu dash is the real part of your permeability, and the epsilon double dash is the imaginary part of your permittivity, and mu double dash is imaginary part of the permeability. So with this one we know that from the question here that mu dash is 1, mu double dash is 2, and so it's and epsilon dash is 1 and epsilon double dash is 2. So once you plug in this formula into this equation alpha, you get alpha as also we have to find omega naught. Omega naught is simply given by omega naught is equal to 2 pi by lambda, which is 2 pi by This is again C by F, which is again 2 pi F by C, which comes out to be, I had calculated this before, and this comes out to be 22 pi by 3. Okay, so now we have all the things which we need, and you just plug in everything and you get the alpha as 44 pi by 3. So alpha is 44 by 3, so you just calculate E T10 equal to, so if you just plug in that 10 into e raised to minus alpha z, z is equal to 10 centimeters, so ET10 is equal to 0.1 volt per meter. So this is how you would solve such a problem, and it's quite complicated if you don't know the formula, the right formula to apply. I would suggest you to make a cheat sheet of all the formulas in electromagnetic theory, and it's best if you memorize them and apply directly in the exam to get quicker results. Thanks for watching. Please subscribe to our channel and push the bell button. Thanks.